Using RMAN to create backups. The content of this nugget serves as a capstone to what we've covered in the previous 5 nuggets. Thus far, we've introduced you to a lot of backup and recovery, primarily backup terminology, and we've spent a little time using the Oracle Recovery Manager tool. In this nugget, we're going to go to the next level. We're going to understand formally the different backup types supported in RMAN, and we're going to run through a very comprehensive demo in which we do the most common backup methods in RMAN. The image file backup, the whole database backup, the so-called fast incremental backup. That is going to involve a little discussion to make sure we understand our terms. Those who are coming from the Microsoft backup world are going to be a little confused at first because Oracle seemingly gets its terminology backward. In point of fact, as you'll learn, it's Microsoft who has the backward terminology. But that's a story for another time. We'll do duplexing and understand the difference between a duplexed backup and a multiplexed backup. There is in fact a difference. And then we'll cover archival backups, basically making a copy of a backup set for archival or long-term storage purposes. We're going to understand what multi-section backups are, compression, and then a little bit on RMAN reporting. We now know how to store RMAN repository data in the recovery catalog. We're going to learn the 2 major commands we use in RMAN to query that repository. We're covering a lot of important exam objectives here, so I hope you're ready to learn. Let's get to work. Types of backup. Some of this is a little bit of a rehashing of what we've covered earlier in the course. We need to understand that there's 2 main types of backups in Oracle RMAN. There's the image copy and the backup set. The backup set is the default backup type in RMAN and is really the preferred way to go. In the real world, you'll tend to use image copies only when you're doing what's called a one-off backup. In other words, you're outside your normal daily or nightly backup routine and you just need to create a quick copy of a data file or a table space, perhaps for development or testing purposes or troubleshooting purposes possibly. So an image copy is a bit-for-bit duplication of a data file or a table space. Now some things to consider with image file copies or image copies is that number 1, you can't compress them because they're, like I said, bit-for-bit duplicates. Basically, it's the same thing as using the CP or copy commands depending upon your operating system and doing an operating system file copy. Another thing is that the target type for image copies is disk only. You can't do the SBT target or system backup tape. Another reason why image copies are used by some folks is that they give you a faster restore, because essentially you're just going to take your image copy backup and slam dunk it where the failed file is and go from there. But again, the default way to backup in RMAN and suggested way, in other words, the approach that gives you all of the Oracle bells and whistles and features, is the backup set, which is a logical collection of elemental units called pieces. Now, the downside to the backup set is that it's proprietary. Only Oracle tools by default are going to be able to understand those pieces and be able to put those pieces back together, take them apart, etc. With an image copy, like I said, it's just a file copy, so you can do pretty much whatever you want with that backed up copy and with whatever tool, operating system or otherwise, that you choose. With backup set, you're pretty much marrying yourself to RMAN. For the purposes of the certification exam, consider yourself happily married. Another element of the backup set is that because they're logical entities, they're going to consist of more than one data file, control file, or archived redo log file by default. Now we can customize the behavior of backup set creation. We can customize the maximum size of each backup set. We can customize how many files maximum can be stored in each backup set. So we have a lot of flexibility on how Oracle will create and manage backup sets, including, down at the bottom here, the ability to assign more than one backup set per channel. You'll remember that a channel denotes an Oracle server process that's responsible for streaming data in a backup or restore situation. The max set size backup parameter controls that. types of backups continued. When we run a backup in RMAN, by default it's going to be just an ordinary garden variety full backup in which all data blocks that are indicated in the scope of the backup are backed up. And if we run a standard traditional backup every night, then we're going to wind up with backup set results that are probably going to get a little bigger throughout the week, but we're still storing a lot of redundant data. And that's going to be a problem for many reasons. Number one, you may have a relatively small backup window and you just don't have the time available during the work week to run a traditional full backup on your production database. Number two, we have on the other side of the coin the recovery or restoration window, and we want to be able to quickly restore elements of a database or an entire database in a catastrophe. That actually might work to your advantage if you're doing a full every night, because then we don't have to worry about querying multiple backup sets. In most cases though, backup administrators are going to want to run an incremental backup scheme such that we have a baseline traditional full backup. Maybe we would run that on the weekend, maybe a Saturday, and then for the remaining days of the week run an incremental backup that backs up only changed blocks in the database from either the previous incremental or the previous baseline full. Now here's where we need to pay particular attention because Oracle uses a different terminology than is found in Microsoft. And if you do the research, it turns out that Oracle is using the industry standard nomenclature here, and Microsoft kind of gets things backwards. So pay close attention. If you're interested in running incremental backups in Oracle Database 11G, the equivalent of the full or baseline backup is called a level 0 backup. And that's going to be the same exact thing as a regular full backup, but when you specify level 0, Oracle assumes that this is going to form the backbone or base of an incremental backup strategy, okay? So keep that in mind. So once you have your level 0, again, maybe Saturday night, subsequent nights you would run a level 1 backup. And this is going to include changed blocks from either the previous incremental backup, the previous night's backup, or the previous level 0 foundation backup. And you can run these backups either consistently or inconsistently, as we talked about before. Cold meaning we take the database down and we guarantee consistency between the control file and the redo log files and the data files, or we do it hot with the database online. And that's going to be up to you. Is your database used during the weekend, for instance, when you want to take your level 0 snapshot? I would assume the database probably is in use during the work week, even at night. So most Oracle administrators tend to go the online or hot backup route. Now we'll remember that archive log mode needs to be enabled for that database in order to do a hot or online backup, because we need those archived redo log files to perform database recovery to bring the database into a consistent state upon restoration. And consistency is going to be assured if we have a graceful shutdown only. That is, if we plan to do a cold backup and something goes kerflunky during the database shutdown process, then we're still going to have an inconsistent backup. You'll want to resolve that problem first and make sure that you can do a graceful shutdown to ensure that the data is in fact consistent. Alright, now, where do things get confusing? So far, you Microsoft folks are probably thinking, well, so far so good, I understand the difference between full and incremental. Let me pop out onto the web in the really great Oracle Database Backup and Recovery User's Guide. This is an excellent book. I am looking at the Release 1 version, but in this case it doesn't matter. There's a chapter called RMAN Backup Concepts that has a subsection called Incremental Backups. And this is cool because it very nicely defines the difference between the two types of incremental backup. Now you might be thinking, what? Two types of incremental backup? Yeah, actually the default level 1 backup, the level 1 incremental, is formally called a differential incremental backup. And that's the crux of the confusion for folks from Microsoft land. Microsoft administrators are accustomed to a differential backup being a backup that backs up any changed blocks only from the previous full. So the idea is that in Microsoft terminology, you're going to wind up with your baseline level 0, and then each subsequent night, the differential is going to get bigger and bigger because it's backing up changes from the level 0. When in point of fact, in Oracle terminology and in standards terminology, a differential incremental backs up all blocks changed after the most recent level 1 or the baseline level 0. Okay? So you essentially just have to either think opposite to what you're used to in Microsoft terminology or just scratch your previous understanding and go with what we have here. By all means, for your exam success, you need to understand this. Now, in Oracle terminology, what we just defined as the Microsoft's differential backup is actually called a cumulative incremental backup. And that's going to back up all blocks changed after the most recent incremental backup at level 0, and the differential type is the default. So you may be wondering, well, how do we specify that in our backup statement? Let me answer that to you right now. See, we've got some supplemental information here. See if there's anything we haven't actually covered. This is an important point. If you're going to do incremental backup in Oracle Database 11G, you have to use backup sets. Can't use image copies with this scheme. And again, that makes sense logically because the image copy is a file-to-file, bit-by-bit copy. So by definition, we're not doing any incremental or differential stuff at all. We've already covered the weird nomenclature in terms of differential versus cumulative incrementals. Let's get to the meat and potatoes, and we're going to see this in the upcoming demo. I just wanted to show it to you here really quickly in code, that to create our baseline level 0 database backup, we would log into RMAN and run backup incremental level 0, and then whatever you're backing up. Database would be the most logical option. Remember, just running backup database does not create a level 0 incremental backup. You have to specify incremental level 0. And then to run a normal incremental backup, a differential incremental, you would say backup incremental level 1. So that's what you would run on subsequent nights, and each night Oracle would look back to find an associated level 0. Now what if there's no level 0 available? Then we can rest assured that this is going to fail. If we want to do a cumulative backup instead of a differential incremental, we would run backup incremental level 1, and then here's the catch. Cumulative database. You see? Final point I want to make here is that you can run incremental backups on the database, obviously, but you can also run them on the data file and table space level, but you cannot do incrementals on granular units like the control file or the archived redo log file. Those are not allowed to be backed up incrementally. You have to back those up full every night. Also, backup sets as a whole cannot be looked at or examined by Oracle incrementally. It would probably require too much processing power. A possible point of confusion among some Oracle backup administrators is the issue of plexing backup options. Now, they're perplexing for sure, but we're going to straighten that out right now. Specifically, we're talking about the difference between a multiplexed backup set versus a duplexed backup set. Let's look at duplexed first because it's easier to understand. All a duplexed backup set is a redundant copy of a backup set. Okay, simple as that. You may, for instance, have a database for which you want to run your backup, and maybe you're doing a disk to tape archival system, but you also, maybe in a one-off situation or as part of your standard routine, want a second copy of each night's backup to bring back in your development environment so your developers have live data or relatively current data with which to work. That's a very common use case where you'd want more than one duplicate, duplicate, get it, of that result. Now, how do you do that? Very, very easily. In your backup statement, you just specify the copies clause. In this example, we're specifying device type disk, which we could omit if we have device type disk set as our default device type in our RMAN configure run. But the copies clause is crucial. Anything beyond copies 1 is going to result in a duplexed backup set. So in this example down below, we would set copies to 2. And then we can use the format clause to specify our results. Now, since I changed copies 3 to copies 2, I'm going to strike the last entry here. But basically, as you know, we're just specifying a destination path for those results. Oracle will allocate a channel automatically for each disk device. We know how to configure parallelism to specify a cap or maximum number of channels. Otherwise, Oracle 11G's automatic channel allocation will pop stop those channels or spawn those channels as it needs to. So that is duplexing. There's nothing more to it than that. Now, multiplexing is a little bit different. You'll remember from previous examples of using RMAN that you have a channel that represents a server session, and normally that channel is going to associate only with a single file. So we might, for instance, want to spawn a couple channels using allocate channel, and then when we look at what RMAN is doing behind the scenes, because we know that RMAN echoes its activities very nicely, we might find that channel 1 is handling file 1 and channel 2 is handling file 2. Now, for speed of backup, you might want to consider multiplexing, especially with many files in a database, basically to aggregate your processing power. So what you have in this example that I've pulled from the Oracle documentation is a single channel, a single server session, backing up blocks from more than one file into a single data set, or a backup set, I should say. What controls that are a couple parameters, files per set and max open files. So if we have this backup running with files per set 3, then we can rest assured that each channel is going to have up to 3 channels. Each channel will have up to 3 files running through it. Max open files is going to, again, constrain how many of these multi-file server sessions you can have going. So there's definitely some performance tuning elements here. If you crank these values up too high, you may bring your server to its knees performance-wise because these channels may be overburdened. So you want to be careful to tune for performance without unduly affecting the overall performance of the server, if that makes sense. Another term for us to understand for our exam success as well as for our industry success as Oracle DBAs is the multi-section backup. This is a fairly recent feature added to Oracle, and basically what we're solving here is we have a really large data file of at least 1 gigabyte, and instead of constraining that file to a single server process, which is the default behavior, we can actually have more than one channel working on that file at the same time. So let's look at our RMAN, not our MOM, sample code that I've given you. In this example, in this run block, we're allocating 3 disk channels, and then in one fell swoop, we're going to specify a multi-section backup of data file 3. So what we're doing here is running a backup data file 3, which looks in the database index, data file index, locates that particular data file, and by saying section size 700 megs, we're going to run a parallel backup in which each of those 3 channels will handle upwards to 700 megs worth of that file. You see what I'm saying? So again, this is like a multiplexed backup going to be done for performance reasons where we want to lower or make smaller the amount of time it takes to back up our data. In other words, to reduce our recovery window. Now this feature, multi-section backups, of using more than one channel to back up a single database, or data file I should say, gives us what's called a parallelized backup because we have more than one channel working in parallel. And we can query from SQL Plus the $v backup set dynamic performance view to see what's going on in terms of any files that have been backed up in a multi-section way. We're really relying heavily upon RMAN and its repository to know how to put those pieces back together, no pun intended, in the event of a recovery situation. We're getting close to the demo, I promise. An archival backup is an exam objective and a concept that refers to backing up a backup set. You may have requirements, industry, governmental legislation, or just security policy within your organization that denotes that each night's backup, or maybe one backup a week, needs to be archived in perpetuity, in other words, forever, in an off-site location. How can you do that kind of stuff? Well, we can run the duplexed backups like we learned before, but you can also back up entire backup sets, especially to different form factors. For instance, as I've mentioned so far, many organizations will do a disk to tape backup. The idea is that because disk to disk is so much faster than disk to tape, we can get our backup done as quickly as possible, and then we don't have to worry about backup window when we're doing our archival backup from disk to tape, you see? Now in this example, we are running the commands one after the other, so in actuality, you'd probably want to run each of these at slightly different times. But in this run block, we're first going to back up the database plus archive log delete input. That's going to back up everything. The database, the archived redo log files, and delete input, you might remember, removes the archived log files from their original location to save disk space. The idea is Oracle has successfully backed up the archived log files. We can nuke the ones that are in the production location and just make room for more. Second statement in this example, backup device type SBT, which is tape. You'll need to do some additional configuration to specify your media manager target. And then backup set all is going to grab any backed up backup sets and shuttle them to your tape device. Final point before we get to our demo is a little bit on RMAN reporting. Now, RMAN is cool in terms of its power, but we want to make sure that it's doing what we instruct it to do. Chances are it is, but as administrators, we would definitely be well advised to follow the old saying, measure twice, cut once, and trust but verify. Essentially, we have two RMAN commands that we can use for reporting. Either command works with or without the recovery catalog. You're going to have a wider and deeper scope of info in recovery catalog, of course, as previously discussed. There's list and report. Now, list is your in and out fast command. It's going to show you data that needs a backup. It's going to show you expired backups. It's going to allow you to get a good insight in terms of what database backups can be purged if you're not using the flash recovery area. You can query your stored scripts. You can query your incarnations. If you need more detailed reporting that involves analysis, that's where we would use the RMAN report command. So basically, list is just going to take a quick look in the repository and come back with numbers for you. Report is going to perform some deeper analysis. Again, it's going to give you more information on what needs backing up, what's obsolete, information about the database schema, and also, again, with an eye toward analysis, any problems that it detects. This is where you're going to verify your backups and look for corruptions. Alrighty, well, let's get this party started. Welcome to this wild and woolly demo in which we move our skills with RMAN and Oracle Database 11g backup to the next level. We are on our trusty server, OraNugget, and as you see, I've logged into SQL+. I've done so using the sysdba privilege, and I'm running show parameter recovery just to take a quick check of the location of our flash recovery area. And on my server, you see that DB recovery file dest is set to EFRA, and that the maximum size is 10 gigabytes. So that's cool. I'm going to exit out of SQL+, and we'll log into RMAN, and we're going to get into reporting functions in line with the demo. Instead of separating reporting from these advanced backup skills, we're going to integrate it right in. And in other words, we can do a report schema to get a really nice detailed view of our data files, as well as which table space each data file is associated with. Isn't that cool? Now that's going to come in handy in just a little bit when we do data file level backups. For instance, if you wanted to back up the user's data file, how in the world would you know what file ID it was? Because you'll remember that the syntax for doing that is using the data file number. In fact, why don't we actually start with that? Come to think of it, we probably should configure our RMAN environment first. So let's do a show all and see what our settings are currently on this server. Looks like everything is set to default values, so why don't we just quickly tweak up some of our RMAN defaults. Let's configure our maximum backup set size, that is max set size, let's set it to 2 gigabytes. Let's also configure our disk device, configure device type disk to a parallelism setting of 3. In other words, we'll cap the number of channel threads. Let's configure control file auto backup. That's very easily done, you'll remember, like so. And let's do retention policy too. We'll do a redundancy too. All right. One final thing we'll do, let's change our backup set defaults to compressed backup set. So let's do a configure device type disk, backup type to compressed data, compressed backup set. That's going to allow us to cover the exam objective dealing with compression. And encryption works the same way, really. We would just run configure encryption for database on, and we would specify the appropriate encryption algorithm. AES 128 is the default. You also, if we want to, who can change the compression algorithm if we want, but I think we're pretty good with what we have. Now, back to our regularly scheduled programming. Let's start with our use of the backup command to do image copies. So we're going to start with taking the whole database as an image file copy, and we're going to use the flash recovery area as our destination. So I'm simply going to do backup as copy database and let that run. The RMAN repository, because we're connected to a target database, the repository knows where to find each of those data files, and as you see, we're enumerating those right now. Our default device type configuration in RMAN is disk. That's why we're seeing that echoed on these alternating lines. And we also see on this line starting data file copy. It's telling us when each file is complete as well as its elapsed time. Now you might be wondering, why do we have 3 data files being handled at once? Remember, we set our parallelism to 3, so that means Oracle is going to spawn up to 3 different channels as it does its work. I don't really have a lot of data in this database, so it doesn't take all that long to complete the backup, fortunately. We can dip out into our E drive, FRA, which is our flash recovery area, and see, sure enough, we have separate folders using Oracle managed file conventions dealing with our auto backups, our backed up redo logs, as well as a folder called data file. And as you see here, there's no compression. These are just the actual raw data files that come from the database. So that's potentially a lot of space, but that demonstrates what that does. And matter of fact, we don't need to actually go through it, but we could also do backup as copy table space and then specify the friendly name of that table space. That would be useful for capturing an image file copy of multiple data files that are associated not with the whole database, but with just a single table space, okay? Now, if we want to grab a single file, that brings back the report command. We can run report schema again to get a list of data file names, most importantly their ID number, their current size, and their associated table space. So if we wanted to grab the users file, which is ID 4 on my database instance, I can type backup as copy data file 4 and just let it go to town. Now again, remember, we're going into EFRA because that is the flash recovery area on this system. If you want to redirect this backup to another location, we would just throw in the format clause with an alternate path in single quotes, and RMAN would send that file to that alternate location. Just to demonstrate that, I'm going to do a backup as copy data file. Let's just grab, how about 5, or whatever that 5th file is. It looks like an example data file. I'm going to throw in format E backup 1, and I'll call this example _01.dbf, and let's go to town. And yet again, because we specified parallelism 3, that not only gives us an upper limit to channels, but also gives Oracle permission to spawn as many channels up to that number that it sees fit to complete that backup. And that didn't take long at all, 7 seconds on my system. And if we come back to our drive E, go into backup 1, we see the example 01 DBF file, just bit by bit copy of the source file in that location. And because this database is running in archive log mode, we're able to do all this in a hot or live environment, which is pretty darn convenient, I think you'll agree. Now, as far as entire backups, just whole database backups, we've done quite a bit of that thus far, actually. You'll remember that we can do a backup database and just go to town with that as the default and leave everything in RMAN alone. We can spawn additional channels or fewer channels if we want to. We can add a format clause. If we run backup database plus archive log, that includes our archived redo log files as well. Now, if we add yet again delete input, that's going to remove the archive logs from the disk after they have been backed up. So why don't we try that next? And just by way of review, although I'm issuing these backup statements directly from the RMAN prompt, we can go about this in so many different ways. We can create an external RMAN script file if we want to. We can create a stored script if we're using a recovery catalog, or we can save that script to the file system with, say, the RMAN extension and call it. So many different ways to go. However, in this particular nugget, what we're concerned with is using the backup command in many different ways. Now, one thing I want you to see in this output, I know that the output's a little intimidating when you first see it. When we use list and report, we can get some of this information in a little more user-friendly of a way. But I want you to see that for every backup set that's created, we have one or more pieces. And you see here that the piece handle consists of the name of the file, again by default using Oracle Managed File syntax, and you'll also see references to tags. A tag is an optional identifier that we administrators can add to our backups in order to make them, yet again, more easy to read for us. So tags are really a good best practice to use. We're actually going to check them out right now. I'm going to hit host so I can get out into the command prompt environment, clear the screen, and then we'll exit the host command and come back into RMAN, and let's go right into incremental backups. And this time I'm going to add a little spice to the procedure by including a tag. Remember that the difference between backup database and backup incremental level 0 database is that we can only use the latter option when we want to build an incremental backup strategy. So we need a good level 0 backup first before we do any level 1s. So let's do backup incremental level 0 database, but I'm actually going to throw in a tag here. I'm going to call this level 0 base. Now you'll see that the file names created in each backup piece include the tag embedded in them, level 0 base. A little bit easier for us to see at a glance, especially when we're in the file system, to know what's what with those files. Now if we want to run a level 1, similar syntax, backup incremental level 1 database, tag, I'm going to call this one level 1 underscore diff because the default incremental type is a differential backup, isn't it? Because we specified backup compression as an RMAN default, you see here on this line that each channel is starting a compressed data file backup set. By the way, this time that we're spending in learning to parse and understand the RMAN feedback here is going to pay off handsomely on your certification exam because you may very well be asked to interpret this output on your own, and you want to be well armed to do that. Now that ended really quickly, of course, because there's no changes in between the level 0 and the level 1 that you just saw. Finally, I'm not going to actually put this through, but if we wanted to do a cumulative or a true differential backup, our syntax is backup incremental level 1, cumulative, and then the object database, and then tag if you want to do that. Cool. Let's now do some more reporting. A command in RMAN that you should be familiar with is crosscheck backup of database. And this is going to check out and look for the status of backup pieces that it finds. Another command that's cool, just give you a snapshot of what's going on with your RMAN repository, is list backup summary. And this gives us a really succinct list of our backups. F stands for full, A is archive log. We have level 0s and level 1s shown. Compression, remember that archive redo logs can't be compressed. And then tag. This is a case where the tags become helpful. We have the original default tags that Oracle gave us here, and then once we started adding our own tags, in particular for our level 0 base and our level 1 differential incremental backup, it becomes much easier to see that, isn't it? Now, as far as plexing is concerned, let's try duplexing next. Here's what's going on. When you want to send multiple copies of a backup, and it can be any kind of backup, database, tablespace, data file, we just specify the copies clause. Let's do a backup device type disk copies to database. Get a new line with an enter key, and we'll format that such that we go to ebackup1, and we'll use a unique identifier, %u substitution variable, comma, and then specify another path, unique identifier, and then letter rip. So we spawn our pre-configured channels, and we start rocking and rolling, doing that database backup, sending one copy to my backup1 folder, the second copy to my backup2 folder. Now let's take a look at the file system and make sure that that actually happened. Let's go back to our E drive, backup 1, Take a look at the files. Backup 2, same files. So it looks like we're good. It created that redundant copy for us, exactly what we wanted. Now how about multiplexing data files in a backup? Remember that that's where a single channel can handle more than one file, which is different from the default behavior that we're used to seeing up above. Now how can we do that? Well, let's do that in a run block. So we'll open up a run block and we'll allocate a couple channels. I'll say C1 is my first channel, device type disk, and we're going to specify max open files is 4. And we get an error message stack. This is a simple syntax error, isn't it? No big deal. We can start again. Allocate channel C1 device type disk. There we go. This should work better. Max open files 4. We'll do the same thing for a second channel. This specifies what's the maximum number of data files that can be open at once and serviced by that particular channel. And now we're going to do a backup database throwing in files per set. I'm going to say 4. Files per backup set is 4. We're backing up the database. And I was thinking of doing a format, but we really don't need to here. Let me just throw in a semicolon and let's get this done. Of course, we need to close the run block with a closing curly brace. No semicolon after that curly brace, remember, and then we'll start the work. And you see here that C2 is handling 3 different files, sysox, example, and undo tbs01. And C1 is handling the system data file. That's pretty fast. Wow. For a full backup, that was pretty much the fastest backup we've done thus far. Another thing we can try is a multi-section backup. This is where we have more than one channel backing up a large data file. Now let's again use our trusty list command, list schema. Whoops, it's report schema, not list schema. Well, there is a 1 gigabyte minimum to running a multi-section backup. You see that we have just a little over halfway there with the system data file. Guess we could always add a data file to the database that meets that size requirement. To do that, why don't we go through the Oracle Enterprise Manager, and from the Server tab we'll come to Data Files, and we'll use the Create button. I'm going to call this users_2. I'll leave the file directory alone. That's Oradata ORCL is where all the other files are located. I'm going to set the size to 1500 megabytes, and I'm going to specify just typing. We could browse if we wanted to, but I'm just going to type in the users table space. I'm going to set auto extend on in an increment of 100 megs with an unlimited max size. Now let's show SQL here to see exactly what's happening behind the scenes. We're running the SQL DDL command, alter table space, users, add data file, and then there's the path to the file. Size is 1500 megs, auto extend on, max size unlimited. Why don't I throw a DBF on here just to be official, and we'll click OK to proceed. Alrighty, well there's the file. Let's come back into RMAN, clear the screen, run report schema one more time to see what's going on. And yep, we do have our new file. It looks like it's file ID 6. So what we can do is, I'll do this again in a run block to make sure I'm encapsulating everything I need. We'll allocate channel C1, device type disk. I'm just going to use my buffer using the upward arrow to save myself some typing, and I'll left arrow over to change the ID of each of these channels. I'll add one more, and I'll call it C3, logically enough. And then to do a multi-section backup, we'll just do backup, section size, and then whatever increment you're interested in. I'll say 500 megs. Data file ID is going to be 6 here. Let's close up our run block, and let's get this done. Boy, that was super fast, let me tell you. Using RMAN to create backups review. Boy, we covered a lot of ground in this nugget, a lot of exam objectives, but I hope if you've been following these nuggets in this series sequentially, I hope that none of this came as a big shocker. As I said at the opening slide of this nugget, what we've done here is really put a cap on the skills that we've been building in the previous 5 nuggets. We now have a very comprehensive understanding of backup-oriented terminology, and there's a lot of it, as we know. There's the difference between a full backup and a full level 0. There's a couple different level 1s that we now understand. We know how to use RMAN to do image file copy backups, database backups, incremental backups, duplex, multiplex backups, and backups of backup sets, so-called archival backups. We understand things about multi-section and compressed backups, and we even understand the list and report commands a bit in terms of querying the RMAN repository repository for metadata. I'd like to give you a hearty congratulations if you understand everything we've covered thus far, because we have in fact covered a great deal of information. I hope that this has been informative for you, and I'd like to thank you for viewing.